So if you are finding it hard to study the TCA cycle and you have been reading it every time, you don't even understand what they are saying, stick to the end of this video, because in the end of the video I'll be giving some useful mnemonics that you use to understand the TCA cycle very well. The tricarboxylic acid cycle, or you call it the Krebs cycle, or you call it the citric acid cycle. Stick to the end of the video. And if you are just joining my YouTube channel, make sure to subscribe and turn on your post notification button so that anytime I drop any video, you'll be notified every time, because I drop useful short videos and content, and I explain every topic based on anatomy, physiology, medical biochemistry, and pharmacology and pathology. All medical videos that are needed for you. So always subscribe and watch my video. Anything you need is in my channel. You get it now? So let us jump right into the video. Now, TCA cycle, or we call it the tricarboxylic acid, or you can call it the citric acid cycle, or you can call it the Krebs cycle. It's a continuation of glycolysis. So when there's increased amount of oxygen, what you call it oxidative phosphorylation, what happens? Don't forget, pyruvate is shunted out into the inner mitochondrial matrix for formation of for ATP. So pyruvate, once it forms acetyl-CoA, it undergo 8 steps in the TCA cycle, entering the electron transport chain for the formation of ATP. So follow it, watch my glycolysis video, watch the transition step, and now you'll be in TCA cycle. You understand it very, very well. So the TCA cycle is a metabolic or a biochemical pathway which is needed for the formation of ATP. So all our energy currencies were formed in glycolysis, which is NADH. Now, if they enter into the TCA cycle and enter into the electron transport chain, they can form ATP. Don't forget, the TCA cycle is very, very important, because we'll also be forming CO2. In this reaction, we'll be forming various things. And your TCA cycle is very, very important, because other non-carbohydrate sources like amino acid and fat forms intermediate of TCA cycle. They form intermediate of this reaction. So it's very, very important. So we formed ATP here very, very well, and this can be an intermediary for other non-carbohydrate source to enter to also form ATP. So it is very, very important. It's just 8 steps, and we have 3 irreversible reaction. 3 irreversible reaction. Why in glycolysis we have also 3 irreversible reactions: step 1, step 3, and step 10. But in this one we have step 1, step 3, and step 4. So stay with me. So now the first reaction we'll be doing here is that we'll be forming citrate. Formation of citrate. Citrate is formed. Now we have formed acetyl-CoA. Acetyl-CoA is formed from pyruvate. So acetyl-CoA, 2 moles of acetyl-CoA will be condensed with 4 moles of oxaloacetate. So 2 moles of acetyl-CoA will be condensed with 4 moles of oxaloacetate to form citrate. So the first reaction here is formation of citrate. It's an irreversible reaction. So the condensing enzyme here is citrate synthase. So the condensation enzyme here is citrate or synthase. This condensation enzyme condenses acetyl-CoA, 2 moles of acetyl-CoA with 4 moles of oxaloacetate to form citrate. So don't forget it. Also, the inhibiting here, NADH can also inhibit this reaction. ATP can also inhibit the enzyme. So now we have formed citrate. So citrate can be isomerized to form isocitrate. Citrate can be isomerized to form isocitrate. But before it gets isomerized, it will undergo 2 stages. First of all, the dehydration stage, where you remove water to form 6 isocitrate. So first of all, citrate will form 6 isocitrate by removing water. So now when it forms 6 isocitrate, the next one here will now add water back. From 6 isocitrate, we can now form isocitrate on this one. So you remove water and you add water back. Which enzyme here is the enzyme here is Aconitase. The enzyme is Aconitase. Aconitase can be inhibited with fluoroacetate. We call it rat poison. Don't forget. Then isocitrate now will form α-Ketoglutarate. Isocitrate will form α-Ketoglutarate by what enzyme? Isocitrate or dehydrogenase. Isocitrate or dehydrogenase. Also, this reaction is taking 2 ways. This reaction will take 2 ways. First of all, the isocitrate will form oxalosuccinate. it will form what? Oxalosuccinate, or you can call it oxalosuccinic acid. So isocitrate will form oxalosuccinic acid by isocitrate dehydrogenase. So again, isocitrate will form what? Oxalosuccinate, or you call it oxalosuccinic acid by what? Isocitrate dehydrogenase, utilizing what? NAD plus to NADH. So when we utilize NAD plus to NADH, by reducing it, we now oxidize isocitrate to what? Oxalosuccinate. Now we can also use magnesium and manganese as the coenzyme here. Now oxalosuccinate or oxalosuccinic acid also undergo decarboxylation here. Oxalosuccinate or oxalosuccinic acid undergo decarboxylate using the same enzyme, isocitrate dehydrogenase, to form what? Alpha-Ketoglutarate. So the conversion of isocitrate to alpha-Ketoglutarate involves two reactions. The first reaction, we are forming oxalosuccinate and we decarboxylate to form alpha-Ketoglutarate. Don't forget. Now we are from alpha-Ketoglutarate, but one thing you need to understand: 4 moles of what OAA, oxaloacetate, condensed with 2 moles of what Acetyl-CoA to form 6 moles of citrate. 6 moles of citrate is isomerized to 6 moles of isocitrate. 6 moles of isocitrate now is being decarboxylated by isocitrate dehydrogenase to form 5 moles of alpha-Ketoglutarate. Don't forget it. Now we are in alpha-Ketoglutarate. What happens? Alpha-Ketoglutarate utilizes the same complex reaction used in transition step, but in this one is what? Alpha-Ketoglutarate dehydrogenase complex. It's a very large dehydrogenase complex we are using here. So this dehydrogenase complex we are using here now uses the same E1, E2, E3 we use in the transition step. The same thing. So we all know how it forms. Now we are transferring inside CoA inside the group by a transacetylation enzyme. Now we are decarboxylating using what? Alpha-Ketoglutarate what? Dehydrogenase, where we do oxidative decarboxylation. We add CoA inside, and the last one we now oxidize the reduced lipoamide to the oxidized form. So when we are oxidizing the reduced lipoamide to the oxidized form, what happens? We are utilizing what? NAD plus to NADH. So now in this reaction, we are also forming what? 2 moles of what? NADH. So the first one we formed was in step 3. The next one we are forming is in step 4. So 2 moles of NADH is formed in step 3. Now we are forming another 2 moles of NADH in step 4. In this reaction, 3 things occur. We add CoA SH, we decarboxylate, and now we are reducing what? NAD plus to NADH. Now when we undergo all this step of using what? Alpha-Ketoglutarate dehydrogenase complex, what do we get? We convert alpha-Ketoglutarate, 5 carbon alpha-Ketoglutarate is formed into what? 4 carbon of what? Succinyl-CoA. Succinyl-CoA. You see, alpha-Ketoglutarate does not have CoA, so we use transacetylation to give it CoA. Now we decarboxylate from 5 carbon to 4 carbon, and the last one we reduce NAD plus to NADH. Now we have formed a Succinyl-CoA. Now Succinyl-CoA utilizes what? Succinyl-TCA or Succinyl-CoA Synthetase, utilizing GTP. So Succinyl-CoA utilizes what? Succinyl-CoA thiokinase or Succinyl-CoA Synthetase, utilizing GTP to GDP. Now when we convert GTP to GDP, there's a loss of phosphate, and that phosphate is added to what? ADP to form ATP. So in this reaction, we have what we call substrate level phosphorylation. The substrate level phosphorylation is formed in step 7 and step 10 of glycolysis and step 5 of TCA. What happens now when we are converting Succinyl-CoA? We form what? Succinate, using what? Succinyl-CoA thiokinase or Succinate Synthetase, utilizing GTP, and at the end we form what? ATP, using the process of substrate level phosphorylation. Don't forget, in step 5. Now our succinate is being oxidized. Our succinate is oxidized to what? To fumarate. Our succinate is oxidized now to what? Fumarate. Now in this oxidation of succinate to fumarate, what happens? We are reducing also FAD plus to FADH₂. So we are utilizing vitamin B2 here. The coenzyme here reducing what FAD plus to FADH2. What enzyme? Succinate what? Dehydrogenase. So succinate dehydrogenase catalyze the oxidation of what? Succinate to fumarate, reducing FAD plus to FADH. This reaction can be inhibited by what? Malate. Now, since we have understood, now we have formed fumarate now. Fumarate now can be what? Hydrolyzed to form what? Malate by the addition of water. So when you add water to fumarate using the enzyme fumarase, you form what? Malate. Don't forget, malate. So fumarase is hydrolyzed by fumarase to form malate. Now we are formed malate. This is our step what? 7. Now we are formed malate. So malate now can be oxidized using malate dehydrogenase. Malate can be oxidized using malate dehydrogenase to form what? Oxaloacetate. Oxaloacetate. So when you oxidize malate to form oxaloacetate, we will be reducing NAD plus to NADH. So don't forget, in step 3 we are forming 2 moles of NADH. In step 4 we are forming 2 moles of NADH. In step 5 we are forming ATP using our substrate level phosphorylation. In step 6 we are forming FADH2, and in step 8 now we are forming NADH. All this will be using in the energy world profile. Now we are from OAA now. OAA can now enter into the electron transport chain for the formation of what? ATP. And also OAA can be also condensed back with what? Acetyl-CoA to form another citrate. So the reaction keeps what? Going around. So I hope you understand it now. OAA is very, very important. From OAA too, also, if the glucose level is low, we'll talk about that in gluconeogenesis. If the glucose level is low, OAA can be converted to malate. The malate will be shorted out from the mitochondria into the cytosol for the purpose of what? Gluconeogenesis. We'll talk about that one later. So hope we have understood now the biochemical pathway of what? TCA cycle. Now the next we'll be going into is the energy profile. In the energy profile of TCA cycle, what happens now? Where are the places we are forming ATP? Same thing we do. Where are the places we are forming what? ATP. We form ATP now, first of all, in step 3, where we have 2 moles of NADH. So when we have 2 moles of NADH, what happens? 1 mole of NADH is forming 3 ATP. 1 mole of NADH is forming 3 ATP. So 2 moles of NADH will form what? 6 ATP. So we are forming 6 ATP in step 3 using what? Isocitrate dehydrogenase. In step 4, we are using α-Ketoglutarate dehydrogenase complex. Then we are getting what? 2 moles of what? NADH. So therefore we form 6 moles of ATP. Don't forget, any place we see 1 NADH is forming what? 3 ATP. 1 NADH is forming what? 3 ATP. That means 2 NADH will form what? 6 ATP. And now we should now know that we form 2 NADH in step 3 and we form 2 NADH in step 4. Also, now we have how many now? 6 ATP plus 6 ATP. We have 12 ATP. Now in step 5 we are forming ATP there. And which ATP we are forming? We are forming what? 2 ATP using what? Substrate level what? Phosphorylation. In step 6, your succinate dehydrogenase is forming what? 2 moles of FADH2. And I told you that 1 mole of FADH2 is giving us 2 moles of what? ATP. Then now we have 2 moles of what? FADH2, we'll be getting what? 4 moles of what? ATP. So 6 from step 3, 6 from step 4, 2 ATP from step 5. So 6 plus 6, 12. 12 plus 2, 14. Plus now 4. What will it give you now? 18. So we are forming 18 mole now in step 6. Now where do we form ATP again? Now in step 8, what happens? In step 8, we now have what there? We have what? We are forming 2 moles of what? NADH2. NADH. So if we have 2 moles of NADH, I told you produce how many ATP? It will produce what? 6 ATP. So 18 plus 6. 18 plus 6 will give us how many? 24 ATP. 24 what ATP. So since now in the total TCA cycle we are having 24 what ATP. Now this 24 ATP now, if we add 24 ATP plus the 6 ATP in the transition step, how many will you giving us? You're giving us 30 ATP from the transition step to the what, to the TCA cycle, 30 ATP. But in the total cellular respiration, we'll be adding the aerobic glycolysis plus the TCA cycle. So if there's high amount of oxygen, aerobic glycolysis will be shunted into the mitochondria to undergo what TCA cycle. So total will be forming is 38 what ATP. So if there's constant supply of oxygen from glycolysis to TCA, will be forming what 38 ATP. But if there is no oxygen or the oxygen level drops, don't forget, we'll form 2 ATP. Why? Because our 8 ATP formed from aerobic glycolysis, when we form pyruvate, is shunted to form what lactate. By then we are losing what 6 ATP. 8 minus 6 will be giving us 2 ATP. So if there is no oxygen, you'll be forming 2 ATP. But if the constant supply of oxygen, glycolysis will continue as TCA cycle to form 38 what ATP. Don't forget. The next we'll be talking about the regulation of TCA cycle. How can we regulate? Always remember, I tell you, you can regulate them dietary, hormonally, and allosterically. Dietary, hormonally, and allosterically. In your dietary regulation, what happens? Remember, same thing with glycolysis. When you increase fat state, when you increase the level of carbohydrate, what happens? You stimulate what? Glycolysis, and you stimulate TCA cycle. When you constantly eat carbohydrate is being absorbed by the muscle, and when it's absorbed by the muscle, it undergo what? Glycolysis, and the same thing for ATP formation, it undergo TCA cycle. But when you are starving or doing starving or what, fasting or what, strenuous exercise, what happens? TCA is inhibited. TCA is inhibited, where OAA, like I said, is shunted out using malate to form what? Glucose, through the process of gluconeogenesis. So at this stage, TCA is what? Inhibited. From my pyruvate, instead of me to form acetyl-CoA, I'll form what? Oxaloacetate, which I'll be talking about in the later form of the gluconeogenesis what? Video. So don't forget it. Fasting, starvation, strenuous exercise inhibits TCA cycle by also inhibiting glycolysis. Why our fat state increase in carbohydrate, what happens? It favors what? TCA what? Cycle. Hormonally too. Hormonally, like I said it also, hormonally, when there is increase in carbohydrate food, what happens? We stimulate insulin from the beta cells of Langerhans. Insulin stimulates protein phosphatase. And protein phosphatase does what? Stimulates the what? Dephosphorylation reaction. So when we are dephosphorylating the reaction, we are converting pyruvate to acetyl-CoA, and which favors what? TCA cycle. Don't forget. So insulin increase the absorption of glucose for what? Glycolysis, and also stimulates pyruvate dehydrogenase what? Complex, which stimulates what? TCA formation. But now, if there is low amount of glucose, what happens? The body will start what? Breaking down other sources, other non-carbohydrate sources, and also breaking down our glycogen, which will also inhibit TCA cycle, like I said. So we'll be stimulating glucagon in that process, and pyruvate dehydrogenase complex will be what? Inhibited. And when they are inhibited, what happens? We will be what? Converting what? Pyruvate to what? Oxaloacetate directly, instead of pyruvate to what? Acetyl-CoA. The last one, allosterically. Now if you want to allosterically inhibit it, now what happens? We will be inhibiting what? The key enzyme, which is what? Citrate synthase. We'll be inhibiting the next one, which is what? The irreversible reaction, which is step 1, step 3, and step 4. Citrate synthase, isocitrate dehydrogenase, and what? α-Ketoglutarate dehydrogenase complex. So all of them basically can be inhibited basically by ATP and NADH. ATP and NADH, and they can be stimulated by what? Increase in pyruvate and also ADP. So when you increase pyruvate and ADP, you favor pyruvate to form acetyl-CoA. But when you have a high amount of ATP and high amount of NADH, what happens? You inhibit pyruvate dehydrogenase complex, or you inhibit any of these 3 allosteric enzymes we have what? Mentioned. But also one thing you want to understand also, excess amount of acetyl-CoA also inhibits pyruvate dehydrogenase complex, which inhibits TCA cycle formation. Don't forget. So next is the mnemonics. The mnemonics I'll be giving you is the mnemonics for TCA cycle, and don't forget this mnemonics. Now always remember, citrate is Krebs starting substrate to form oxaloacetate. Citrate is Krebs starting substrate to form oxaloacetate. So citrate is the first part, is isocitrate, Krebs is α-Ketoglutarate. Don't worry, citrate is Krebs, so the Krebs part is α-Ketoglutarate. Starting is Succinyl-CoA. Starting is Succinyl-CoA. Substrate is Succinate. Substrate is Succinate. So don't forget, citrate is Krebs starting substrate to form. Now the 2 is subtle, so the 2 is not part of the mnemonic. So now form is fumarate. Form is fumarate. Oxaloacetate is the last substrate. So citrate is Krebs starting substrate to form oxaloacetate. So we have run it: citrate, isocitrate, α-Ketoglutarate, Succinyl-CoA, Succinate, fumarate, and malate. So I hope it all made sense and you understood all the pathways and the way I've broken down, giving you a mnemonic from citrate to oxaloacetate, and how oxaloacetate enter into the electron transport chain to form what? ATP, using the energy currency. I hope you all understand it and you understand the energy profile on how we converted pyruvate to what, the mitochondria, from the cytosol to the mitochondria, and anaerobic glycolysis, what happened to ATP. Aerobic glycolysis, you have 8 ATP, but if there's continuous supply of oxygen, we form what, 30 ATP plus 8 to form total of 38 ATP. So I hope you understood it. So if you are new to my channel, make sure to subscribe and turn on your post notification button so that anytime I drop any video, be sure to be notified. And you have to go back, always watch all the video. If you want to understand, you have to start from the beginning, which is the glycolysis video, and work your way up to this place, and continue watching other videos. And if you want me to make a video for you, drop it down in the comment section and I promise I'll make the video for you. So we'll be seeing ourselves in the next video. Always continue staying and stay to the end of the video, because I'll be giving useful mnemonics at the end of the video. Okay, see you in the next video. Bye.